so I was working in the epidemiology unit here 3 and a bit years ago. But since then, I've been at Our Future Health. Can I just get a show of hands for who is familiar with Our Future Health? Okay, because the first part, I was just going to go straight into genetic data, but I've borrowed some slides from someone just to give a bit of a background to Our Future Health, and I'll go through that quickly, but it might be useful. Okay, I was also asked to show this slide here, which is an upcoming series of webinars about, I think it's about access to Our Future Health and about how researchers can get involved, for those who aren't already involved. So if you're interested, there's an email address there. I think I've shared these slides, so you should be able to get that as well. And then there's a bunch of webinars coming up in April, May, and June. Okay, here's the agenda. Like I said, I'll start with an overview. So the whole kind of background to this is a big collaboration between funders and charities. We need the funders to help us along, as well as the government, but also the charities to work closely with us. And so the point of the whole thing is to help people live healthier lives for longer, as all cohorts are, I guess. We're a not-for-profit, a charity, and I guess one way that we differ is that we're quite tech-led. So from the very beginning, we were heavily into the tech side of things, which has both been, it's like a startup effectively. When I started, there was 20 people working there, now there's 300. So it's been interesting to watch that growth over the last 3 and a bit years. And like I said, we're trying to build a cohort. There is lofty aims for 5 million volunteers. I'll show some numbers coming up about where we are at the moment. And then we're now moving into a phase of engaging with researchers and working with researchers to understand exactly what they want. Going back to the previous talk about the TREs as well, about how it's best to access the data within the TRE and any pain points that are happening early on. I'm hoping to get involved with some of that work. We're also providing personal disease risk information to the participants. That work is kind of now ramping up. So things like PRS, we hope to give back. Yep, okay, sorry. Okay, done that. So I guess one thing we're trying to make sure is the volunteers represent the UK and have a slightly different age range to previous cohorts. So there's big push to get multi-ethnicities across the UK as part of the cohort, and non-Europeans, and young people and over 60s. So this differs slightly to previous cohorts similar to this. And this is what you might expect. You might go to a thing in a car park, you might go to Boots, you might go to Tesco, they're all over the place now. But you would complete a questionnaire, you would do some physical measurements while you're in the clinic, and you would give a small blood sample for the genotyping, and then that's where all the DNA comes from and all the genetic data that I'm working with. And then there's teams working on the linkage data and working with the questionnaires and how we join everything together. And then there's recontact studies that are coming in the future. Okay, so this is the kind of trajectory. This is probably out of date. I think October 2024. So you can see the different lines that represent the different kind of states of completeness that a participant might be in. So there's somewhere between 2.5, 3 million registered. But at the very bottom, a full participant is someone who's registered, done the questionnaire, given blood, the blood sample is good. So the data that I work with can only be involved with those people in that red line. So we're currently, past 1 million. I mean, we'll get to those numbers, but we now have 1 million people, kind of full participants. It will be 2 million at some point in the near future. Let's see if this works. This, I think, technically is an animation that the CTO made on a hackathon. Until I'm not a PowerPoint user, there we go. Well, I'm just going to hit space and see what happens. Oh, there we go. So I think this is probably out of date, but it's just a history of where the participants have come from. And you can see that the focus initially was in the major cities and in England, and then we are now moving into Wales, Scotland, Ireland, and that data is coming through. But there are still some kind of dark spots I'm from the northwest, I'm from Cumbria. There's not much in Cumbria at the moment, which is not good. But those things are happening now with remote kind of sites opening in car parks and stuff. Let's see. So onto the genetic data. It might seem strange to be working with genotypes. It's quite old kind of style data in a way, but it's still the most cost-effective way of doing this at this kind of scale. And we do use it's a standard backbone, but we've been working with our industry partners to add additional variants, 700,000 variants covering various key targets, and also aim towards this PRS for the participants. But lots of different kind of reasons that this set of variants has been chosen, not least for this pharmacogenetic variant analysis. But 700,000 variants can then lead to about 170 million variants once it's been imputed. So we're now imputing these data via the UK Biobank reference panel to increase that number to a much more reasonable amount. And researchers, they like genotype data, but they want the imputed data. Okay. So this just gives an idea of where we are in compared to the actual UK population and our participants. I won't go into that too much. You can find all this online as well, I think, but the overall story is we're doing pretty well. And again, by age and sex, and ethnicity, and IMV quintiles, again, it's a pretty representative cohort. And this is the only slide on TREs, but now we do have much more data than this. This is one of the old releases, but we have 600,000 genotype arrays, questionnaires for over 1.5 million. And we have our first little bit of imputed data. If you're special, you can get access to that. But this is just a test run to see if it's working. But the next phase is coming this year. Okay, so just background. You can thank Ryan for those slides because I borrowed them off him. Ryan actually was part of the IU not so long ago. And this is the squad that I work with day to day. Ashley was also at the IU not so long ago. Apologize for taking people from the IU, but that's the nature of the business. And so it's quite a small team considering what we're doing. Other cohorts and other kind of approaches like this would have a much bigger squad. All right, how long have I got? 10 minutes. So genetic data, for those who don't know, most of you probably do, it is quite weird. The release that we have at the moment, almost half of the file types in there are kind of bespoke to genetic data, which means that when you're working in a large organization that's working with standard data, CSVs and JSON and stuff, you're on the periphery of what everyone else is doing. You're an outlier. And so the first 2 years have been trying to convince the organization that genetic data is different and needs to be handled differently and just can't throw into the same, standard Airflow, Dagster style pipelines, all this stuff. So that took a little bit of persuasion, but now we have our own we have our own nodes, we have our own setup, we have our own kind of compute infrastructure, and that has helped massively. The data is often redundant, so for those who know VCFs, the first 9 out of the 10 columns for each of our participants is identical. It's incredibly wasteful, but that's just the way that we get the data. So when you convert that into a release, you're losing 90% of the data straight away. It is quite large. It's not as large as some data sets, but we have 4 different values for each genotype, for each variant, for each participant, which is about 2 trillion data points for the last release. And once you get into the TRE and the researchers are interacting with 2 trillion data points, things get expensive. And they don't need most of those. So we're spending a lot of time actually reducing that down because the first pass was just let's give them everything. And then afterwards, researchers say we don't want everything, it's too much. So, and like I said, researchers want the data, they want the imputed data mostly though. And again, for those who know, genetic software is often really frequently file-based. Let's turn one massive file into another massive file. There's not much take-up outside of the bioinformatics community. A lot of it isn't cloud native because of the historic on-premise HPC way of doing this stuff in the past. And a lot of it isn't really production-ready, single-threaded kind of, that you have to work with it to make it go fast. Okay. So going back to what I was saying, scaling for us has been a problem because one half of the organization is working with questionnaire data and linkage data, which is very kind of, it's one type of data, and we're working with a different type. So scaling has been a lesson in kind of describing our problems to the organization and explaining why it's difficult. We also have the constant withdrawal issue. So every time someone withdraws, they have to be taken out of the data. And so if we just kept the data as one big release, you'd have to go into that remove participant. It's hard work. So that's a big challenge. And everything gets slower as the cohort gets bigger. And we have things that work for now, but we're working on alternatives. So where are we up to? I mean, I wrote this bombastic statement, but I think we've probably built, in the quickest time, one of the most advanced genetic processing pipelines in the world. I'm allowed to say that. It's difficult to prove because you can't see it, but the fact that we've done this, the fact that we've done it in 12 months is quite impressive. Like, we were given a lot of help from around the organization to work with the infrastructure we had in place, but for a small squad to do this was pretty good. And we've met all deliverables, and but we have got a lot of technical and data debt. We have hard deadlines we have to meet to keep everyone happy. If we don't meet them, we don't get money. So yeah, we've left a little bit of a mess behind, but we're still tidying up. Okay. So like I said, we've actually received now data from over 1 million participants. Amusingly, we've actually QC'd 2 million, and that's because we've had to reprocess a lot of the data. We've had to put a lot back through the pipelines. So 2 million people have been through. That's petabytes of data, probably. We can now release that data for millions of participants in under 24 hours. Press a button, 24 hours later, new release comes out. And like I said, within 12 months of getting the data, we had a release of 606,000 participants, which was pretty frantic. And we now have this data flow to Genomics Limited, through to UK Biobank on their wrap, back to us for the imputation. The future is, at the moment, we're investigating ZAR. Now, ZAR is a data format that's used widely in the weather industry for multidimensional matrices. It also fits VCFs quite well. VCFs are the way that we store genetic data and the way that we receive it. In the simplest format, you get one big VCF file, samples and variants, but with ZAR you can distribute it into chunks based on fixed numbers of variants and samples. Fortunately, this paper was being written at the same time, and we collaborated on this paper with groups from around the world. It's just been accepted in GigaScience, it's coming out soon. And so this is how groups around the world may start to work with VCF data. There is a preprint actually of this with the same title that you can read now. But it was really interesting to see how this came about, how these groups got involved, in particular NVIDIA. So there's part of this paper shows how you can use this format directly on graphics cards to do AI, and that massively reduces the costs of a lot of the downstream analysis. So that's really exciting. That's what I'm working on right now, how this might help us, how we can replace the standard tooling with this format and with all the downstream tooling that this provides. That's it. That's 20 minutes. Thank you.